And the other part was prey-predatory model. The prey-predatory model is based upon the exponential growth model. Remember, the competition model was based upon logistic growth model, whereas prey-predator models are based upon exponential growth model. So if you get an idea, the prey and predators have an interdependent relationship. Okay, in the absence of a prey, predator will decrease. In the presence of a prey, predator will increase. Okay, similarly, in the absence of a predator, prey will increase exponentially. You can understand that. Okay, in the absence of predator, there will be no one to check the population of a prey. Let's say if there is no cat, then the population of mouse will grow on. If there is no predator, mouse or any prey's population will go on increasing. Predator help in keeping check at the population. We understand that the prey's population will increase in a manner of R into N. We know that dn by dt. Okay, the population growth depends on intrinsic rate and that of the population size, right? But so this is the scenario in the absence of predator. When there is no predator, prey's population will grow on increasing exponentially. But when there is a predator present, the population of prey will decrease. In the presence of a predator, in the absence of predator, it will increase, obviously. Okay, in the presence of a predator, it will decrease. But how much? How will that decrease? The decrease will happen in this manner. That means, let's say a cat is catching a mouse. Okay, a cat is catching a mouse. Here, the cat has to struggle through capturing that mouse. Okay, we studied the foraging includes different cost and benefits and different processes, in which one of which is capturing the mouse. Okay, so how much can that capture? What is the capturing efficiency of that? Let's say a cat can capture 4 mouse. Okay, so that is the capturing efficiency. One cat or one predator can capture up to 4 prey items. So that is the capture efficiency. That much of capturing can be done of that by predator. So if one cat can catch 4 mouse or mice, what will happen if there are p number of cats? So they will catch this much, let's say, so if 4 into p, right? So if c is the capture efficiency, so it will be c into p into the number of species. So this is how the number will decrease, right? We can simply count it out. You can understand that if one cat captures 4 mouse, you can see that 1 p is capturing 4n. Then if p number of p's will capture how much? 4 into n into p, that is c into n into p. Okay, you can easily get that. So this is how prey number will decrease, as because these much of cats are capturing these much of mouses. So this is the rate of decrease in case of prey population. Now what will happen to the predator population? Now the predator population in the absence of prey will decrease as well. So the only factor that will lead to the decrease in case of predator is mortality. Okay, as because predators have no other factor to be decreased of, so the only thing that can reduce down the predator is the mortality factor. Okay, but how will predator increase? The number of predators will increase on the basis of this much. Okay, I mean the availability of prey as well as the population birth of new predators. Okay, apart from normal efficiency of the predator, that is one predator or this much of predators can capture this much of prey. If there is an increase of population, let's say if their population is increasing in case of predators, how much will it increase with respect to the birth that happens? Let's say one predator is giving rise to 2 individuals. Okay, so that will be included in that. If the predators are increasing with respect to that, then the birth will be included with respect to the hunting capacities or capturing capacities, right? So it will be multiplied. If you're getting the idea, preys increase with respect to r into n in the absence of predator, but when the predators are present, they will eat down the preys. But how much of preys they will eat? So there is the capture efficiency and the capture coefficient. Okay, the capture rate. So this is the entire capture rate, how a predator will capture them out, and how the prey's number will decrease. So how will predator increase the number? The predators will increase the number by one, the availability of birth, and the other availability of prey. Okay, and then there is decrease in case of predators. How will the predators decrease? They can only be decreased by death, as because they don't have any other factor to be by killed off. The only thing that can reduce the number of predators is death. Okay. Now, if we put that in a sort of equation, then we can see that the change in population in case of prey population is this much. So if we totally add it up, so this is the increase versus this is the decrease. So rate of change of population will be the increase minus the decrease. Okay. So this is the scenario. So when the prey population growth is 0, when there is no growth happening, if we are taking isoclines, okay, this is to take out isoclines. When will be the population 0? When P equal to R by C. Okay, so this is the zero growth isocline for that of the prey. Okay, similarly, this will be the zero growth isocline than that of the predators. So the change is again increase minus the decrease. So we'll take out and we'll find that when the number of individuals of that of the prey is equals to this much m by bc, then this will be the zero growth isocline, and when the predator population is r by c, then that will be the zero growth isocline of the prey. Okay, so all of these are based on the assumption that prey species grows exponentially without a carrying capacity. Okay, so this is the assumption that they have been taken up, and there is no immigration or emigration of individuals of the both of species. There are limited number of individuals which are interacting within each other, and the birth and death that happens is again dependent on prey availability. Okay, and again each of the birth that happens is discrete. So one particular species is laying birth, that means one individual is laying birth to two individuals, and two will lay out birth to four, two and two, and so on. Okay, so that sort of interaction will continuously happen, that is over multiple generation discretely. So it's not like that that one of the individual will give rise to one individual, another will be two, and they'll increase for three, and one will go for one. It won't happen. So the assumption is everyone is giving equal number of births, and that is our discrete generations. Okay, and again one particular assumption is predators can consume unlimited prey. Okay, it's not like that they have taken into account of how much of predator can take up, but they have assumed that predator can take up onto unlimited amount of prey. So these are the assumptions that have been taken up. Okay, and other assumptions are the prey available is only one and the predator available is only one. Okay, so if the prey is not available, predator will die off, and if the prey is available, then that has only one predator. Okay, so these are the assumptions. So these are the assumption to understand how the cycle of prey and predatory works out. Okay, so let's take this into account. We have understood in the last models and competition models that if it is below the isocline, it will increase. If it is above the isocline, it will decrease. But here it is bit different. Here it is bit different because in this case of competition model, the competition was interrelated, but in the sense they were competing for a particular resource. Here the resources are interrelated. Okay, there they were competing for a particular resource. Here the resources are interrelated. So the thing is, a bit of change will happen in the sense the availability of prey will decide the availability of predators. So when we talk about prey and predator isoclines, it is important to understand that the prey isocline looks like this. Now this is the prey isocline where the predator number, if reaches R by C, then the prey growth will come to a standstill. The prey growth won't happen positively. Okay, that is at this particular point the growth of prey is constant, okay, or kind of zero. Okay, above it will reduce, it will go in minus, below it will be positive, right? For example, let's say when the predator number is 10, when the prey number will reach to a point of maximum growth, and after that it will start reducing. Okay, so this is the point of isocline for prey number, and above it will decrease, below it is increasing. Okay, when the predator number is about this much, this is the prey isocline. The prey number will reach to its maximum point. Okay, the prey growth will reach to its maximum point. So if you put this in such a way, then we'll see that so below the isocline the growth will increase of prey, and above the isocline the growth of prey will decrease because the number of predators are more than that of the isocline. So this much of predator will equate this much of prey, which will be the equilibrium state. So this is the point of equilibrium. Above it, the prey number will decrease as because the predator will be more in number, and below it, the prey number will increase because the predators are less in number. Just to make it clear, let's say the predator population when is 10, the prey will reach its maximum growth. Okay, when it is 8, they can still increase. Okay, when there are less population of predators, the prey will increase definitely. When there are large number of predators, let's say 12 or 15 or so, obviously there will be more to eat the prey, hence the prey population will decrease. So this is how a graph will look like. Similarly, reverse thing will happen in that case of predators. Now this is the predatory isocline where the prey number is like that. So up to this point, the prey abundance is highest. Okay, so up to this point the predatory abundance will increase. So in case of predatory isocline, so this is the point at which when the prey number is this much, above it the predator number will increase, below it the predator number will decrease. So this is the equilibrium state, or let's say the minimum amount of prey availability that a predator can sustain. Below it, the number of predator will decrease. So this is the availability of minimum sustainability for the predator, because below that, when the prey number is less, then the predator number will go down. Above it, when it is more number of preys are available, the predator number will increase as well. So it is a bit complicated, but just to understand, here we are saying about prey population with respect to predators. Okay, prey population with respect to predators. The predator population increases leads to decrease in the prey population. Okay, when the predator population increases, it leads to decrease in the prey population. So this is the isocline which tells about how prey population is regulated by this number of predators. Okay, above it, it will decrease. Below it, the prey population will increase. Whereas in this scenario, this is the minimum sustainability for a predator to sustain this number of preys. So when preys are in this number, which is the isocline, the predator can sustain. Above it, they will grow because there are lots of preys available. Below it, they will decline. The population will fall because there are less amount of preys present for sustainable development of the predators. Okay, so this is predatory isocline, which talks about the availability of prey, the number of preys, whereas the prey isocline talks about the number of predators. So okay, this might be confusing, but this is the entire thing. So if we club up, we'll get this sort of idea. Below the predatory isocline, okay, below the predatory isocline, the number of predators decreases below the predatory isocline. Okay, above the predatory isocline, the number of predators increases because there are lots of preys available. Similarly, in this case, let's say there are 100 preys. So this is the equilibrium. Okay, we know that 10 predators can eat 100 preys. I mean 10 each. Okay, so when the predator population is 10, but the prey number goes to this much, now all of them get around 9 preys, which is not sufficient. So few of the predator will feel weak or may reduce or may die off. Okay, and when the prey number increases up to this much, then there are predators around 10, so each of them are getting 12. Now they can reproduce and produce more kind of predators, which will be available to eat more available preys. Okay, so when the prey number is increasing, obviously the predator number will also increase with respect to the available prey. When the prey number is reduced, which is below the isocline, the predator number will also decrease. Okay, so this is the basic idea on which the entire theory is established upon. Okay, so when we put this, we'll get the idea. Above the prey isocline, the number of predators are more, hence the prey will decrease. Above the prey isocline, prey will decrease because the predators are more in number. Below the prey isocline, the prey number will increase because predators are less in number. Okay, this is the important thing. You have to remember that above the prey isocline, predators numbers are more, hence the prey population will decrease. And below the prey isocline, because the predator numbers are less, the prey isocline number is increase. Whereas in case of predatory isocline, the prey number is less, Hence, below the isocline it will decrease. Usually below the isocline every point increases, but here, as because it is talking about prey population, and if prey population is less, predators will decrease as well. But when prey population is high, that is above the isocline, the predator will increase. So this is interrelational. So this is the only different or important point to remember. Okay, so when we put that in a collective scenario, so when we put it up in this graph, we'll see that below the predatory isocline, the predator number will decrease, which is marked as pink or red, whereas below the prey isocline, prey will increase. Below the prey isocline, prey increases. Below the predator isocline, predator decreases. Okay, so the direction will be like this. Here we are seeing that predators are less in number, whereas preys are increasing. So there is an increase in prey. Okay. Next, when we move forward, we will see that the prey population will increase because that is below the isocline, whereas predatory population will increase because it is above the isocline. So you'll get this sort of increase. Here, what we are kind of seeing is, as because the prey population is increasing, the predatory population also increases. Okay, both of this. Right. In the next scenario, we will see that as because it is above the predatory isocline, the predator population will increase, but the prey population will decrease because it is above the prey isocline. Right. So when we pull it up, we will see the increase in predator population. As because the predators are increasing, the prey will get down in population, or the prey will decrease. Okay. Moving forward, when we see this, here what will happen is, as because it is above the prey isocline, the population will decrease, and as because it is below the predator isocline, the population will decrease as well. So here what we'll see is, we'll see decrease in prey population as well as decrease in predator population. Okay, so this kind of interaction, if you put it in a cyclic manner, you are seeing that it is moving around in a cyclic manner, right? So the prey population interaction happens in a cyclic manner, where when predator population less, prey population increases. Prey population increases with respect to predators as well. When there are lots of prey available, predator number increase. As because predators are more in number, so they eat more of the prey, hence the prey population will decrease. As because less prey are available right now in this particular scenario, the predators number will also decrease. When the predator number decreases, preys are free to move out, hence their population increases. So, and that sort of cycle continues. Okay, so that can be formed in this particular cycle where the increase and decrease are dependent on each other. So if we pull up a sort of waveform, then we'll find when prey population is high, or we can see in this manner, when prey population is increasing, okay, when the prey population is increasing, the predator population is less. Okay, the predator population is less, and when it increases over a particular point, next the predators also increase because there are lots of prey available. As the predator number increases, the prey population goes down because there are lots of predator and they start eating all the prey, and the prey population goes down. As because less food is available, the predator population also will go down, and so on will happen. So we can represent in this manner as well. When there are lots of prey, predator population increases. When predator population increases, preys will fall down because they are being eaten by the predators. As because there are less prey right now, because predators ate all the prey, the predator number will also go down. Now the predator numbers are less and there are lots of free area to move around. The prey can grow on and increase in size. Once they grow on, next the predators will also grow on and the cycle will continue. So this is all about the process and cyclic process of prey and predatory interactions, which is given by Lotka-Volterra equations. Then this sort of interaction is based upon assumptions. So you will not get entirely a waveform and equal amount of movement, but there will be ups and downs. So the natural population also moves around with some variations, but it follows that sort of rule where one particular population increases with respect to prey, and when prey increases, predators come down, and when predators increases, preys come down. So that sort of interaction continues. Okay, so this is it. Thank you.